in the past, forget about containers for some time, how we used to build and how we used to deploy our applications before Docker or before containers, let's say. We need to understand the past and present of deployment approaches. So let's first understand that. Let's understand the past and present of your application deployment. In the past, how we used to do. So, as you guys already know, most of you guys already know, if you want to deploy any application or any software, first and foremost thing what we need? First and foremost thing what we need hardware. 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 What do you mean by hardware? Hardware is your computing network devices like your computing hardware, storage hardware, networking hardware like that. Like CPU, memory. You need a hardware. So olden days, in the olden days, in the initial days of IT, in the initial days of IT, how we used to deploy? We used to call that as a traditional deployment. Traditional deployment in the initial days of IT, like in early 80s, early 90s, in the early 1980, in the early 90s, people used to do this traditional deployment model. They will follow this traditional deployment model. So we have a hardware. Hardware is nothing but like CPU, memory, all those things. On top of that hardware, can we run that software directly without interface between your software and hardware? Can we directly install or run any application on that hardware directly? No. So we used to have what on top of the hardware? We used to have a operating system, OS. OS. So we have hardware. We have hardware. We have a hardware. That hardware is like a computing, CPU, memory, storage, all those things. So in the initial days, traditional deployment, we have a hardware. We have this hardware. This is hardware like CPU, memory, storage, all those things. Now on top of this hardware, we used to configure OS. We used to install OS. What do you mean by OS? Operating system. Operating system. Like Windows operating system, Linux operating. That can be Windows, that can be Linux. Within Linux, you have a lot of Linux distributions like Red Hat, CentOS, Ubuntu, Debian. That can be Windows OS, or that can be Linux OS, or that can be Mac OS. Like that, you have an operating system. So, on top of that operating system, on top of that OS, we will deploy our application. We will deploy our application. We will deploy our application. Your application code, that can be a Java code, or that can be a .NET code, that can be that can be Python code. We will run that application. But can we run that application code? Can we deploy that application without configuring the required softwares, binaries, all those things in this server? Can we deploy that code directly? No. So on top of this OS, what we used to do on top of that operating system, what we used to do? We used to have a required softwares that we call it as a middleware. That we call it as a middleware. Required softwares. Required softwares and libraries. Required softwares and libraries. Required softwares, configurations, your settings, required environment variables, etc. the dependent software's configurations. Then we used to deploy our application code. We used to deploy our application code. Now, this is people used to follow in the initial days of IT in early 80s, early 90s. We call this as a traditional deployment model. So here we used to deploy our applications like this. But here we have some drawbacks. We have some drawbacks here. So what are the drawbacks here? We have, let me explain. Let's say you have a hardware. You have a hardware. This system, you have a hardware. You have this much capacity, this server capacity, this hardware capacity, that server capacity, that physical machine. We used to call it as a physical machine. This we used to call it as a traditional deployment or physical machines, traditional deployment, physical servers. We used to call this as a physical machine, hardware, basically a physical machine or bare metal server. We used to call it physical machine or bare metal servers, all are same. So this hardware, let's say I have a hardware of this much capacity. Just to give an example, I am taking, let's say I have a hardware with a 32 GB RAM and I have, let's say, 16 core CPU. Now this is my hardware capacity. This is my server. This is my server. On top of that server, I installed OS and I configured required softwares like Java software, .NET software, or Python software, required environment variables, required configuration settings. You have done all those things. Then you deployed this application. And this is my hardware. Let's say your application is not utilizing this much resources. Is your resources are getting wasted? Is your hardware resources are getting wasted? Let's say your application is not utilizing this much. Is your resources are getting wasted here? Yes, your resources are getting wasted. Let's say this is the hardware, this is the resources, this much resources are available, and let's say your OS also might take some CPU and memory. Let's say your OS is utilizing maybe 1 GB RAM, 1 GB memory, and your OS is utilizing 1 GB memory, and let's say it is using one CPU, and your application maybe, even though there is a lot of load on your application might be utilizing 2 GB or 3 GB memory RAM, and it is using maybe one core CPU. Then you have a lot of resources available and that is not utilized efficiently here. But you may have a question, sir, can't we deploy other application, other software also? Why I need to waste my resources? Let's say this is my application one. Can't I deploy one more application here? Can't I deploy one more application here? You may have that question. Let's say, can't I deploy one more application here? Yes. But why we should not deploy, or why we can't deploy another application here like this? So let's say this application is causing some issues in the OS level. What is common for all these applications? Your OS, like your storage, your network area, storage area, mount area, all those things is common. Let's say this requirement. Let's say this requirement. Now this application is expecting Java 11 and this application is expecting Java 8. Now, can we run something like this in this server? Can I have a Java 11 and that Java 11 will be used by this application and Java 8 and that has to be used by this application? Can we have something like this? Version conflicts for your applications. If you have like this, you can't do this. Again, you can't run like this directly. And also, even though both are expecting same versions, let's say both are using Java 8. Let's say I installed Java 8, both are using Java 8 only. Now, if this application is causing some issue in that Java, in the JVM, does other application also gets impacted? Because that dependency, that software is common. Let's say this application is causing the issues in the Java. Let's say this application is causing the issues in the Tomcat. Both are Tomcat based web applications, let's say. Both are Tomcat based web applications or Java based web applications. Both are using same resources, like same dependencies. If one application is having issue, other application also gets impacted. Even though you are using two different softwares, let's say you are running Tomcat and you are running database. Let's consider you are running database also in a same server. But what is common for all the applications? OS, underlying OS. OS is common. Like in the OS, kernel. In the kernel, OS is nothing but a kernel. So kernel is heart of the operating system, guys. Kernel is heart of the operating system. Many of you guys might have learned when you are studying degree or engineering, you might have learned what is OS. When I completed my degree, my computer lecturer used to say, kernel is the heart of the operating system. Kernel is the heart of the operating system. So what is kernel? OS is nothing but a kernel. It's a wrap. OS is just a wrapper of kernel. So what is kernel, guys? Any computer graduates? What is kernel? What is kernel? What is the main functionality of kernel? OS is just a wrapper of kernel. Kernel is a interface between hardware and software. Kernel is a interface between the kernel is a interface between the hardware and software. What does it mean? Your hardware, your computer, like your CPU, memory, your computer cannot understand any human readable codes. Your computer cannot understand any human readable code like Java code, shell script code, Python code, .NET code, like that. It will not understand anything human readable code. So your hardware will understand only binary. It will understand only binary. Binary in the sense only zeros and ones. So this OS will act as an interface. This OS will act as an interface or translator between software and hardware. So this OS will act as an interface between the software and hardware. So OS will communicate with hardware. It will take the input or user's input and it will communicate with hardware to perform something. So OS is just a flavor, but in the background it's a kernel. Kernel is heart of the operating system. So kernel is common. Kernel is common for all these applications. Your applications are not isolated. Your applications are not isolated. Everything kernel is common. Guys, don't ask me computer basics. So you should have aware about what is OS and all those things. Don't ask me, sir, what is OS, what is CPU, what is RAM. So this can be your laptop, this can be your desktop, whatever it is. This can be your laptop, this can be your desktop, or this can be a server. Your laptop also has a CPU and memory. This laptop also has a CPU and memory. And also, do you have some OS in your laptop or desktop like Windows OS or Mac OS, like that? Yes. In your laptop also, if required, can you deploy some applications locally in your laptop or your desktop also? Yes. You need to install required softwares. You need to install required softwares and you need to deploy that application. But what I am saying, in that server, in real time, we are not going to deploy multiple applications because for all these applications, that OS, that kernel is common. In the kernel, we have some concepts. In the kernel, we have some concepts called namespaces, like user space. user space or user area, network space, network space, network space, network area, that network space, process space or process area, mount space. Mount is nothing but a storage space. So in the kernel, we have something called namespaces and C groups. So for all these applications, there is no isolation in this user area, network area, process area like that. If some application is causing issue at a process area or network area, does other application also will be impacted if something is happening in that OS, which is common for all these things? Yes. So that's why it is not recommended to run. That's why it is not recommended to run multiple applications without isolation. Without isolation, there is no isolation here. It is not recommended to run multiple applications here without isolation because there is no isolation here. So if I don't run multiple applications, we are wasting our resources here. We are wasting our resources here. Is our hardware resources are wasted here because these resources are not utilized this application? If I run only one application here, it is wasted. So my resources are wasted. Our hardware is costly. So to overcome this one, people started doing the deployments in a different approach that we used to call as a virtualized deployments. That we call it as a virtualized deployments. Virtualized deployments or virtual deployments. Virtualized deployment. So in virtualized deployment, how it works? In virtualized deployment, how it works, right? So we have a hardware. We have a hardware. We have this hardware, and on top of this hardware, you have something like this operating system. We call it as a host operating system. We call it as a host operating system. Instead of deploying that application directly like this, what we used to do basically, here we are going to create a virtual machines. We are going to create a virtual machines using some softwares. We have some software called hypervisors. We have some software called hypervisors. Hypervisor softwares. Using this hypervisor software, we are virtualizing your hardware. Using this hypervisor software, you are virtualizing your hardware by creating a virtual machines. We are going to create a virtual machines. On top of that hardware, we are going to create a virtual machines. VMs. We call it as a VM, virtual machines. While creating a VM, while creating a virtual machine, we can say this virtual machine can be created using this much CPU. Let's say you have your server with a 32 GB RAM and 16 CPU like that. While creating a virtual machine, I can allocate the hardware resources to this VM. Let's say based on my requirement, I can say this VM, I am allocating 8 GB RAM and 4 core CPU to this VM like this. Now, if required, I can create a one more VM, one more virtual machine based on the requirement. We can create a one more virtual machine based on your requirement. Let's say you can create one more VM like this, one more virtual machine like this. And if you still have your resources, you have a hardware resources still in the underlying hardware, you have a still CPU and memory, you can create a one more VM like this. Based on your requirement, you are creating a virtual machines on top of that physical machine, that hardware, like this. Now here in this VM, each virtual machine will have, based on your requirement you can do, based on your requirement you can create something like this. Based on your requirement you can create a virtual machines. While creating a virtual machines you can allocate the resources for that VMs with the help of hypervisor software, and each VM will have operating system again. Each VM will have an operating system. We call this as a guest operating system or operating system. Each VM will have an operating system. Now here, separate OS. Each VM will have its own OS. Now in this VM, in that virtual machine, I can deploy some application. I can deploy that application. This application. Let's say this application with whatever required softwares and configurations. If required, I can deploy like this. Now here, if required, I can deploy another application. If required, here I can deploy another application. That application can be Tomcat, Jenkins, that can be database or anything. That can be a Java based application, Python based application, or that can be a database software, that can be a web server software, whatever it is. You can deploy applications like this. You can deploy your applications like this. That can be any application or any software. Now, here, each VM, each virtual machine has its own operating system. Its own operating system. And this virtual machine is isolated from here. Suppose this application is causing some issues here in that kernel, in that process area, network area, mount area. If anything goes wrong with this application or this OS, do you have any issues with other application here? If something wrong with this one, do you have any impact on this here? No. No, we don't have any issues here. If something goes wrong with this one, we don't need to do anything. Suppose here I deployed one application, let's say in Tomcat. Now I want to redeploy that application. Do I need to stop this server, or do I need to stop some service running in this server if I want to do some changes in this server, this application? No. So each VM is isolated from other. Each virtual machine is isolated from other. Each virtual machine have its own operating system. But what is common for all those virtual machines running in same physical machine? The hardware, this hardware resources, that CPU, memory, that hardware. So what is common for all these virtual machines running on top of same physical machine? That hardware, that hardware. Now using this hypervisor, you are virtualizing your hardware. So using this virtualized deployment, by using or by following this virtualized deployments, that virtual machines, can we fully utilize our hardware resources? Can we utilize our hardware resources more efficiently? Our hardware resources? Yes. So when I discussed AWS also, I have explained this one. When I discussed AWS also, I have explained this one. Here, there are two types of hypervisors. There are two types of hypervisors. What are those two? Those two guys? When who attended complete AWS, that complete DevOps classes, I have explained there are two types of hypervisors: type 1, and type 2. Type 1 and type 2 hypervisors. Examples for type 2 hypervisors: software level hypervisor and hardware level hypervisor. Basically, examples for type 2 hypervisors, I have already told. Can someone tell? So type 2 hypervisors, examples: Oracle VirtualBox, type 2 hypervisors, Oracle VirtualBox, VMware Workstation or VMware that Fusion. Those are type 2 hypervisors. If it is a type 2 hypervisor, this type 2 hypervisors will not work directly on that hardware. That type 2 hypervisors will not directly work on that hardware. We need a OS. On top of that hardware, we need a OS. On top of that OS only, you can install that type 2 hypervisor. That type 2 hypervisor. But there is something called a type 1 hypervisor. Type 1 hypervisors. So examples for type 1 hypervisors, as I already told, there is something called Citrix Zen, VMware ESXi, Citrix Zen, VMware ESXi, Dell servers, like that. So that we call it as a type 1 hypervisors. If it is a type 1 hypervisor, what is the advantage with type 1 hypervisor? We don't need this operating system. This operating system we don't need. It will directly comes with that hardware. That we call it as a bare metal servers or physical servers. That comes with hardware itself. That hypervisor comes with hardware itself. So we don't need any operating system on top of that hardware to create a virtual machines. So if you are using on-premise environment, your own data centers, or you are using cloud, maybe like AWS or Azure or GCP, in the actual data centers, whether it's your own data center or whether it's a cloud managed data center, what type of hypervisors will be used? Basically type 1 or type 2? Type 1. Type 1 hypervisors will be used. Type 1 hypervisors will be used, not type 2. So type 1 hypervisors will be used. Now, in AWS, the guys who already attended complete DevOps program, they can understand. In AWS, we created a virtual machines, that EC2 instances. We created a EC2 instances in AWS. Or if you are already working on Azure, you are creating a VMs in Azure, or you are creating servers in GCP cloud. Actually, those EC2 instance or Azure servers or GCP servers are nothing but what in the background? Those are virtual machines. Those are virtual machines running on top of some physical machines. Those are some virtual machines running on top of the physical machine, that physical hardware. But if we are using cloud, who is going to purchase and manage that hardware, and who will set up the data center, configuring and managing the data center? CSP, cloud. But if you are using your own on-premise data center, on-prem data center, then it is whose responsibility to manage that data center? It's that company that it is our responsibility to manage the data center also. That we already discussed. So using this virtualized deployment, we can utilize our resources more efficiently. Guys, suppose you have a laptop. You have a laptop or desktop with some configuration. If required, can we create a virtual machines within our laptop or desktop also? By using type 2 hypervisors? Yes. So suppose you have a laptop or you have a desktop, using type 2 hypervisors, you can install some software like VMware Fusion or VMware Workstation or Windows. Windows comes with one software called Hyper-V. So by using that Hyper-V also, you can create a virtual machines on top of your laptop also, desktop, like that. So in the real time, we are not going to deploy applications for end users in our laptops in real time, right? In the actual projects, like the applications which is accessed by end users, is it going to be deployed in the developer laptops or developer desktops like that? No. There will be a dedicated servers. There will be a dedicated servers available for end users. In that servers, we are going to deploy the application. That can be a physical server or that can be a virtual server. Now, what is the advantages with this virtualized deployment or virtual servers, that virtual machines? The advantage here is we can utilize our hardware resources more efficiently, more efficiently. So far we deployed lot of applications. So far we deployed lot of applications. The developers, the developers are writing the code. The developers are writing the code. They are developing the code, and the developers are going to maintain that code where developers are going to maintain that code where SCM, centralized source code management systems, centralized source code management systems, like we have a Bitbucket, we have SVN, we have CVS, GitHub, like that. So developers will maintain the code here. Developers will maintain the code here in your SCM. That can be GitHub, that can be Bitbucket, whatever it is in SCM. Developers will write the code. Now, what we are doing when we want to deploy, what you guys have done so far, you guys created an application package. You guys created an application package out of this code. You got this code. You got this code. CI, continuous integration. You got this code. You got this code. You created an application package. If it is a Java based application, you are using build tools. You are using build tools like Maven or Gradle. If it is a Node.js based application, you are using build tools like npm or Grunt. There is some software called Grunt or npm. If it is a Python based applications, you are using some softwares like a pip or PyBuilder, like that, and you are using some build tools to build that application package. If it is a Java based application, you are using Maven or Gradle or Ant, like that. Using that, you are creating an application package. You are creating an application package. You are creating an application package. What that application package contains? What that application package contains? This application package contains only that code. That code. Then this code you are maintaining in a central repositories again. Artifactories. We call it as artifactories. Artifactory managers or artifactories. Examples, what softwares we used, like Nexus or JFrog, like this. We use some softwares to maintain these application packages. That can be Java based application, that can be Python based application, or that can be, yeah, RPM packages, RPM, your OS packages, RPM packages or Debian packages also you can maintain in that artifactories. That can be a Node.js package, that can be application package. You can maintain your software packages like RPM files, Debian files also here. So you are maintaining here for a future reference. In a central location you are maintaining. So if someone need this package, they can get the package from this one, this Nexus or JFrog. Now we are maintaining this for future reference. Now let's say this is your Java based application package. Now after this, what we used to do? Now here I have some server. I have some server here. So this package, this application package I want to deploy, but is it possible to deploy that application package directly without configuring that server? That can be a physical server or that can be a virtual server, without configuring that server with required dependent softwares, configurations and environments. Can we directly deploy this one here, that package? No. So what we used to do here, before we deploy any application, we are configuring that required softwares and configurations plus required environment variables, all those things we used to set up. Then we used to deploy that application code. So this is what we have done. So far, whatever you have done, in which deployment model you guys done, guys? From day one, you guys are using AWS. Is it a traditional deployment or is it a virtualized deployment? Whatever you have done so far in AWS servers or whatever servers you have used, it's a virtualized deployment. It's a virtualized deployment. Now, DevOps came into picture. DevOps came into picture. Development and operations team working collaboratively together to build and deploy the applications quickly with quality product, less time. Suppose if I do it all these things manually, if I do it all these things like getting the code, creating an application package, and taking that application package and deploying in this server, if we do it manually, is it going to do take lot of time? Whenever there is a change in the code, whenever there is a change in the code, I want to do all these things. If I do it manually, it's a lot of time consuming process. Now everyone is following now agile, agile, agile methodology. Like every time, every company is developing or managing that, or agile is one project management tool or project management process. Agile is a project management process. Everyone is following agile methodology to deliver any product or project. So in agile, we may need to we may need to release the application frequently, like a sprint model. We need to develop something and deliver to the client. Client will validate, and again we will keep on adding new features like that. Is it possible to manually build and deploy applications very frequently, like within a day? Lot of times you need to integrate, build and deploy like that. No. So that's why DevOps came into picture. You guys already know what is DevOps, what is CI, what is CD, and all those things. I'm not covering all those things here. Instead of manually doing all these things, we can create a pipeline, CI pipeline, CI pipeline automation, CI pipeline automation. So continuously, whenever there is a change in the code, your CI pipeline can get the code, compile that code, run the sonar scan, run the unit test cases, and it will create an application package. And if you have a CD pipeline also, whatever package that is there here, that package will be deployed in whatever server you want to deploy. If required, you have lot of servers and I want to perform this one configurations. I want to install some softwares and configurations. Can I use some tools again for this one also? Configuring the servers, configuration management tools. What is the most popular configuration management tools? What is the most popular configuration management tools which we learned also as part of our DevOps program? Ansible. So instead of manually configuring these servers, like installing required softwares to deploy my application, we can use Ansible as a configuration management tool if you have a lot of servers to configure. So you can use Ansible for that purpose. Now let's say infrastructure as a management. I am taking some concepts outside of Docker just to give some again basics of DevOps. So infrastructure automation. Let's say I want to create all these servers. I am using cloud. Like AWS. I want to create a VPC. I want to create a network storage servers like that. Instead of manually creating these servers also, whatever servers required for our applications, like required server, storage, network, can we use Terraform in the DevOps? Again, Terraform, infrastructure as a code. These are the DevOps basics. You can use. Now I am not worried about all these things. Let's discuss about Docker. Till here, is everyone clear? Whatever you have learned so far? how we used to build, how we used to deploy our applications, whether you are building manually, whether you are doing automation, that doesn't matter. So, what is physical deployment? What is traditional deployment? And how it works? Is everyone clear now? Then I will start explaining about containerized deployment. This is something new. This is the trend now. This is trend. Everyone is deploying their applications as a containers. Everyone is, most of the companies or most of the projects, most of the applications are running as a containers. Now let's understand containerized deployment. Containerized deployment. What is this containerized deployment? How different it is from virtualized deployment? So far, you guys run your applications or your softwares as a virtualized deployment. This can be your application, or this can be database, this can be Jenkins, like that, whatever it is. You deployed your application as a virtualized deployment. Now let's understand containerized deployment. So what is the advantage with virtualized deployment? We already know. What is the advantages with this virtualized deployment? What is the advantage with this virtualized deployment? The advantages is the advantages. What is the advantage? Guys, we discussed already. The advantage is we can utilize our hardware resources more efficiently. We can utilize our hardware resources more efficiently. Now, let's understand the challenges. Let's understand the challenges or drawbacks of this virtualized deployment. Let's understand the challenges or drawbacks of this virtualized deployment. What is the challenge or drawbacks of this virtualized deployment? Let me tell you. First and foremost thing is each and every VM has an operating system. Does each and every VM has an operating system OS here? Yes. So each and every VM has an operating system. And again, virtual machines are heavyweight. Virtual machines are heavyweight. What do you mean by heavyweight here? It is not like you are not going to weight that machines like it is 100 kg, 200 kg, like that. So what do you mean by this virtual machines are heavyweight? It will take more resources, because each VM has a OS. Does each and every OS also require some CPU and memory for booting the OS? When you are booting that, when you are starting that machine, that OS also will take some CPU and memory. Virtual machines are heavyweight. Virtual machines are heavyweight. Each and every VM will take some CPU and memory. Each and every VM will take some CPU and memory to boot that OS. And again, if you are using some enterprise OS, does the charges is applicable? If you are using some enterprise OS like Red Hat, you are using this one also Red Hat, this one also Red Hat, this one also Red Hat, multiple licenses, OS licenses. Yes. And it is taking more CPU, more memory. And the utilization is more, and it is taking more CPU, more memory. Each and every VM has its own OS. That is one drawback. I mean to say, each VM has its own OS, and virtual machines are heavyweight. Heavyweight in the sense it is going to take more CPU, more memory, because each VM has its own OS for booting the operating system. Next thing is this configurations. This configurations is a big challenge. This configuration is big challenge. Now, let's say this is your dev server. Let's say this is your dev server. Let's say this is your dev server in which you deployed, you installed some configurations, and you have deployed that application. Same application package you are trying to deploy in a production environment. Same application package you are trying to deploy in a production environment. Another server. Let's say you are trying to deploy same application package in prod server. Now, can we do that? Can we do the deployment on this server Can we directly deploy that application, this application code directly here without this step, without this middleware, without this required softwares? Can we do this one without here? No. So your application package is different. Your application package is different. Before deploying this package, we need to configure that required softwares, required softwares, required softwares, that dependencies. Now, if you observe, if you are already in IT, if you are already in IT, you might have observed one thing. You are a tester or a developer. This is common. This is a common word which you might have heard. So most of the testers, most of the testers will come to the developers. Hey man, that application is working fine in dev server. That same application is not working in QA or production. The testers will come to the developers. The testers will screw the developers time and the developers happiness. So testers will come and say that application is working fine in dev server and that application is not working in the production. So what do you do as a developer? What you tell? Developer mentality, I don't know man. Same code I have compiled, I have created that application package. Same package I have deployed in my local laptop, it is working fine. Same package I deployed in dev server also, it is working fine, but not sure why it is not working in the production. As a developer, you will answer that. If you are already in IT, this might have common. This is common for most of the people. I used to also tell like that. When I was working as a developer, lot of testers said like this application, whatever you have developed, what scrap you have developed, man, it is working in one server, it is not working in another server. These type of things will happen. How come that will happen? Why that will happen? What is getting changed for that application? Code is same. Code is same, but what is getting changed? This software's configurations, that middleware, that software configurations. Let's consider this use case. Let's consider this use case. So this application is expecting some software, let's say Java. And in Java, you have Java 7, Java 8, Java 9, like that. Or that application is expecting Tomcat. When you are configuring these softwares here in this server, let's say you might have configured Java 8 and you have set some environment variables, whatever environment variables, that configurations. Like maybe you are tweaking server.xml or you are tweaking that Tomcat users.xml or you are setting some environment variables, whatever is required for that application. You properly set that here, but here you miss to do some kind of a software configurations and environment variables, whatever environment variables it is expected you have not set, or you might be using different versions of the software. Then even though application package is same, is this going to happen? Application works in one environment which is not working in another environment. Is it going to happen? Yes. So this is one more problem. This is one more problem. The dependencies, that software dependencies or configurations is one more problem. So virtual machines are heavyweight. Each VM will have its own operating system. It will take some CPU and memory. This deploying the applications also challenging task. Now to overcome this one, people started thinking in a different way. That is containerized deployment. That is containerized deployment. People started thinking in a different way. They came up with containerized deployment. So using this containerized deployments, what we can do, we can build, we can ship, and we can run our applications as a containers. So now let's understand what is container in an application perspective. In application perspective, in a software perspective, what is container? So container contains everything. Container contains everything. What do you mean by everything here? Application code, plus required softwares, configurations, required environment variables, etc. So container contains everything in the sense the application code, the required software dependencies, everything. So container contains everything which is required, to run your application or software. So container contains everything which is required to run our application as a software. So if I am creating a container which contains everything to run that software, wherever I run that container, is it going to work without any issues? Because using containerization, what we are doing, we are creating a package like this. We are creating a package with these two components. We are creating a package with these two components. Using containerization software, we are creating one more package. Earlier, this is how we used to have, like your software as a jar file, tar file, or zip file, like that. We used to have that application packages like a jar file, a var file if it is a Java based application. If it is a Node.js based application, you are exporting as a tar file or zip file, like that. Based on that software, based on that programmatic language, you used to generate like this. But now, when we are using this containerized deployment, what we can do, we can build and we can ship and we can run our applications as a containers. So container contains everything which is required to run your application. What do you mean by everything here? These two components, your application plus your softwares and configurations and other things. So here we are going to create a one more package. That package contains these two together, that required application code also and required softwares also with required softwares like this. Now, if this is the case, this is, I am building my application as a container. I am creating one more package, and I can move this package wherever I want to move, and I can run this package wherever I want to run. I can deploy this package wherever I want to deploy, and I can maintain this package in the repositories also. The way you are maintaining jar files, var files, like that in the repositories, I can maintain these packages in the repository, and wherever I need this package, I can get the package and I can run the package as a container. Now, if I am building my application as a container, and wherever I run this one, is it going to work seamlessly without any issues? If it is working in one server, like a dev server, that package works in the production server also without any issues, because these two are working, or these two are packaged together. So that is what the meaning of container in software. So here, nowadays, everyone is following this containerized deployment. So let's understand how it works. In the containerized deployment. You have this hardware. That can be a physical machine. This can be a physical machine or virtual machine. You have an operating system. We call this as a host operating system. Host operating system. This we call it as a host operating system, OS. You are not going to deploy that application directly on top of this OS. You call it as an operating system. Guys, this piece here, this can be a physical machine or this can be a virtual machine. Okay, so you have a OS, you have a OS. Instead of deploying like this, instead of deploying like this directly, instead of deploying like this directly here, what we are doing here, we are bringing something called containerization runtime. There is something called containerization software. There is something called containerization software, container runtimes. We call it as a container runtime or containerization software. So we have lot of containerization softwares. We have lot of containerization softwares. Lot of containerization softwares. Containerization runtime or software, both are same. Containerization softwares. We have lot of containerization softwares like Docker, Podman, Container D, CRIO, or Core OS. Like this, we have lot of containerization runtimes like Rocket. So these are the containerization softwares. So using this containerization softwares, what we can do? Using this containerization softwares, what we can do? Using these containerization softwares, we can build and we can deploy our applications as a containers. We can build, we can ship, and we can run our applications as a containers. But out of this one, which is most popular and widely used containerization software out of all these things? You might already heard about the name. By name, at least you heard the Docker. Docker is a widely used, most popular containerization software. So you have that containerization software, that Docker. You can use Docker, that containerization software Docker. Now here I can create a containers. I can create a containers. Here I can create a containers. So this is my container. This is my container. Using this containerization softwares, I can run the containers. This is container. So container contains like this. Inside the container, you will have something like this. Inside the container, you have something like this. But if you observe this diagram, does container has an operating system? Does container has a full-blown operating system? Here, does container has a OS? Does container has a complete OS operating system? No. Now, we are building and deploying our applications. We are building and deploying our applications as a containers like this. That container will have everything, whatever is required to run that software. But the container will not have an operating system, OS. Now, if required, in same system, on top of same OS, I can run multiple applications as a containers. If required, I can run multiple applications as a containers. On top of this same OS, I can run that application as a multiple applications as a containers. But here, each container is isolated from other. How come isolation is happening? Your question here. Sir, you told last time here you cannot deploy multiple applications because there is no isolation. But you are saying now isolation is there. How come isolation is happening? And who is doing that isolation? How each container or each application is isolated from other? Who is doing that isolation? This Docker. This Docker is doing that isolation. That containerization is doing isolation. So how come this isolation is happening? Let me tell you. In the OS, in the OS, I told there is something called kernel. So what is common for all these containers here also? even though all are running in a same OS on top of same system, same OS, what is common for all these containers? The underlying OS. The underlying OS. So Docker is doing what? Docker is doing isolation at one more level. This this hypervisor is doing isolation at what level, guys? If you understand correctly, this hypervisor like VMware, ESXi, or you are using Oracle VirtualBox, or you are using Citrixen, these hypervisors are doing isolation at what level? It is doing hypervisors are doing a isolation at a hardware level. Hardware level. Now, if you observe, I am bringing Docker here. Instead of deploying my application directly like this, here I am bringing one more software here, that is Docker. That is Docker. I am bringing one more software here. I am bringing one more software here like this. That is my Docker software. So on top of this Docker, what we are doing? Using Docker, we can deploy multiple applications as a containers. So I am deploying multiple containers like this. This is container 1, this is container 2, this is container 3, like that. But if I am using this Docker, it is bringing isolation at one more level. So Docker is doing isolation at what level? Docker is doing isolation at a OS level. So Docker is doing isolation at a OS level. On top of single operating system, on top of same machine, we can deploy our applications as a containers, and each container is isolated from others. So who is doing that isolation? That container runtime. That container runtime, example Docker, like this. So if I use Docker, again, in same machine, can I run multiple applications as a containers instead of running that applications in a different servers directly on the VMs? Can I run multiple applications in a same OS as a container using containerized deployment? Yes. Yes. So what is the advantage here? What is the advantage here? Containers are lightweight. How come containers are lightweight? Lightweight in the sense containers will take very less CPU, less memory. How come containers are lightweight? Because does each container has a OS? Is it having full OS? Complete operating system? No. So containers doesn't have a OS. So containers, since containers doesn't have OS, will it be lightweight? Does containers will take less CPU, less memory? Only for whatever software you want to run, it will take CPU and memory. Less CPU, less memory. Containers are lightweight. Containers are quick. Containers are fast. What do you mean by containers are quick? Containers are fast. Within a fraction of seconds, can I start the containers? Can I stop the containers like that? Within a fraction of seconds? Like within no time can I run my containers? Yes. But if it is a virtual machine, does virtual machines are very slow? Does virtual machines are very slow? Because does virtual machine take lot of time to set up, start? You need to set up or you need to spin up some virtual machine. It will take some time to boot all those things. But within that VM, you are running your applications as a containers. Containers are fast, containers are quick, containers will take less CPU, less memory. What is common for all these containers? The underlying OS. But how come isolation is happening? Last time you said there is no isolation if you deploy like multiple application like this. How come isolation is happening? So in the OS, we have very important component called kernel. In the kernel, we have something called namespaces and C groups concept. There is something called namespaces and C groups. There is something called namespaces and C groups. So in the kernel, so you have something called namespaces and C groups in the kernel, guys. In the kernel, we have something called namespace and C group. If you see here, if you want to know internally how Docker is isolating your process, your application. You can see this one. It's very good document here. So is container is a process? Yes, container is one process. So inside the container, some process might be running. That process might be Java process, Tomcat process, database process, like that. So container is nothing but a process, and each process, each container is isolated from other. So the container is basically using in the background Linux kernel features like namespaces and C groups that will isolate your process. That process is nothing but your container. Each container will have some process like application process, database process, Tomcat process, Java process, like that. So this using this namespaces and C groups, each process is isolated from other. So Docker is leveraging the kernel features like a namespaces and C groups concept. So we have a namespaces like a network space, mount space, process space, like this in the Linux. So what actually Docker is doing when we are creating a container like this, the container, this container is going to be created in a separate namespace in the kernel. Docker is actually what it is doing in the background in the underlying host, right? This container, gets created in a separate user area, process area, network area, like that. In a separate user area, process area, network area. In the underlying OS, this container will get created in a separate network area, process area, mount area, like that. Now this container also will be created in a separate process area, network area in the underlying OS, and other container. This container also will be created in a separate process area, network area in the underlying OS. So if something is causing this container, this process, or this application, or this container, this process is causing some issue in this network area, process area, is the other container gets impacted because this is running in a separate process area, network area in that underlying OS, underlying kernel? No. So this way, these container runtimes, these container runtimes are isolating the applications or process from each other. And this container, this Docker, is going to make sure this container will be created in a separate namespaces in the kernel. This will be created in a separate namespaces like user space, process space, network space. Because of that, this container is isolated from other. What is the one more advantage here? Can I run this application on port 8080, and can I run this application also on port 8080, like this? Can I run this application also on port 8080 if I am running as a containers? Yes. Yes. How come? How come? Because as I already told, there is something called network space. There is something called network space in the kernel. You can run programs on any port without conflicting with what is already running. So when I am creating a container, is that container is getting a separate network space in the underlying kernel, underlying OS? Yes. So that's why we can run multiple applications on the same port. But if I don't use Docker, let's say, if I directly deploy my application, is this isolation happen? Like multiple applications, can I run? No. So Docker is leveraging the features like namespaces, separate network space, process space, like that in the underlying kernel. So that's why isolation is happening. And each container will not have an operating system. Because of that, is containers are fast, containers are quick. Yes. And what is common for all these containers which is running in same system? What is common for all these containers? which is running in the same system, that resources. System resources. What do you mean by system resources? System resources, CPU, that's resources, CPU and memory, and also what is common? The host system, that host system kernel. Host system kernel. Now, even though each container is isolated from other, common is this kernel and system resources. Let's say if this container is taking more resources, let's say I have this system, let's say my system capacity is 4 GB and a 2 core CPU. Your OS might be taking 1 GB, 1 core CPU, still have some CPU like 3 GB. If this container is taking more CPU and memory, even though it is isolated, let's say this container is taking 2 GB memory and 1 CPU, does other containers will impact? Even though this container is isolated from other container in a process area, network area and all those things, but if this container is taking more CPU, does this container will impact? Without CPU, without memory, will it able to run? No. Then how can I control that one? Understand guys, someone is saying no. So what is common for all these containers? I told host system kernel and resources. Let's say my system capacity itself is 4 GB. My system capacity itself is 4 GB. This, let's say this is 2 CPU. Now let's say this is 2 CPU or whatever it is. Now let's say your OS will take some CPU. Does this OS require some CPU to boot? Maybe your OS has already taken 1 GB, let's say 1 CPU. And how much CPU and memory is left? Let's say this is my system. I have 4 GB and 2 CPU. If this is already OS is utilized this much, how much is left here? I have 3 GB. Now let's say 3 GB. Out of that 3 GB, it is taking maybe 2 GB and half core CPU. Let's say this container itself is taking 2 GB and half core CPU. Now, will I able to, does this containers will have enough CPU, enough memory if there is a lot of load on this application? If there is a lot of load on this application, do I have enough CPU, enough memory? No. Then, even though isolation is happening, we have a lot of CPUs, lot of memory, like let's say this is taking lot of CPU unnecessarily, we will run out of the resources for this one. So it will impact. Is it possible to share or control the resources also for these containers? Is it possible to control the resources also for these containers? Yes. So what does it mean? You can allocate or you can set the resources while creating a containers. While creating a containers, I can say this container can take only 1 GB and half core CPU, like that. I can set the limits. I can set the limits for resources at a container level. Swapna, check from your side. Most of the cases you are saying not audible, but it is audible for everyone. Check from your side. My network is fine. If it is a problem from my side, it will be a problem for everyone. So check from your side also once. Now, I can manage the resources at a container level. Let's say if I say something like this container, while creating a container, I can say it can take only up to 1 GB and 1 core CPU. Even though there is a lot of load on this application, this process, will it able to go beyond this much resources? Even though you have resources available in the system, will it able to take more than this much? No. So what concept Docker is using in the background to control the resource consumptions for this process, these containers? There is something called C group. There is something called C group. There is something called C group, control groups. There is something called control groups. In the Linux, in the kernel, there is something called C groups. So we are logically isolating your process from each other using that namespaces concept in the background, Docker. And if I want to limit how much memory or how much CPU my process, that container is nothing but a process. So I want to control how much CPU, how much memory process can take, that we can control using C groups. So Linux has a concept of namespaces and C groups. Docker is leveraging that namespaces and C groups to isolate the process, that containers from each other. So is everyone clear what is Docker and how it isolation is happening even though we are running multiple applications? So this much in detail is not required. This much in detail is not required. You no need to worry about what is namespace, C group, and all those things. In the background, Docker will take care. Docker will take care. But it is good to know. It is not like some magic or miracle will happen if you are using Docker. It is doing something in the background. It is leveraging some existing features in the background to do the isolation. So if you know all these things, it will be good to understand all the concepts. Now, what is the advantage? What is the advantage with this Docker? As I already told, you have a hardware, you have an operating system. On top of that operating system, you will have a containerization runtime, and you can deploy multiple applications like this as a containers. Now, you are bringing isolation at one more level, like on this one you can consider. You can consider this one. So this is one VM. This is one VM. On top of that VM, instead of deploying applications like this directly, you are bringing containerization. You are bringing containerization on top of same OS. On top of same OS, we can deploy multiple applications like this. So what is the advantage? Container will not have a complete operating system. Container will not have a complete operating system. So if you don't use containers, do I need three separate VMs to deploy these three applications? Let's say I am not using this containerization software. Do I need a three separate VMs to run these three applications? Yes. If I am using container, can I run that application? Can I run that application? Multiple applications in same OS also? Does OS charges will be reduced if I am using some enterprise Linux? Do I need a multiple licenses here to run these three things? No. Only less licenses, because only one OS, you are isolating your applications at a OS level. Does not require full-blown operating system. And Docker packages are self-contained. Docker packages are self-contained. So can I quickly deploy my application that are Docker packages, because that package contains everything? Do I need to manually do this software setup and libraries to deploy that application if it is a container? No. So you are building that package itself. If it is building that package itself with required softwares and code, can I run that without configuring the required softwares? Can I directly run that package? That package itself has required softwares? Yes. So containers are fast, containers are quick. Now, if something goes wrong with this OS, what will happen to all these containers? Because all the containers are using same OS. Does all the containers gets impacted? Yes. All the containers gets impacted? Yes. Because all are running in top of same OS, it will be impacted, because it is common. OS is common for all those containers, or that hardware, that server is common. So all the containers gets impacted. But there is something called container orchestration, guys. There is something called container orchestration. So using that container orchestrations, we can manage the containers. That we will understand later. First, let's understand containers, then we will understand container orchestration. The container orchestration softwares like a Docker Swarm and Kubernetes. That Kubernetes or Docker Swarm is a container orchestration softwares. We can manage the containers. We can scale the containers. We can load balance the containers using container orchestration softwares like Docker Swarm or Kubernetes. That we will understand later. First, understand container, then we will understand how to manage the containers. If something goes wrong with container, how containers will be recreated or replicated, that we will understand later. Now, the advantages. Let's compare this one. Let's compare this one. The difference between virtual machine and container. This is very, very important in an interview standpoint also. This is very, very important in interview perspective also. When you are attending any interview, if there is a requirement, there is a opening on Docker, that containerization or Kubernetes, they may ask these type of questions. What is difference between virtual machine and containers? So theoretically, I have already explained in detail. I have already explained in this diagram. So what is VM and what is container, how it works, I have already explained. But let me explain one more time in the table. Virtual machine is heavyweight. Virtual machine is heavyweight. Container is lightweight. So each VM has its own OS. Each VM has its own OS. All containers will share the same OS. So here we can, each VM will have its own OS. It's heavyweight. It is heavyweight. It is going to take lot of resources for booting that operating system. Here we will get a native performance. Native performance in the sense, based on the resources available in that host, your containers can utilize. Your containers can utilize your CPU, your memory, like that. Now, hardware level virtualization. So this virtual machine isolation or virtualization is happening at what level? In the VM, that isolation or virtualization is happening at what level? Hardware level. But when it comes to containers, that isolation or virtualization is happening at what level using containers? OS level. So containers is super fast. We can start the containers quickly. When it is VM, it will take some time. So it requires some memory and CPU to boot the operating system. It requires less memory to boot the containers. Containers will take less time. So when it comes to VM, VM is fully isolated. It is fully isolated. VM is fully isolated, hence it is little secure than containers. But when it is a container, what level of isolation is happening? Process level isolation. Process level isolation. So possibly less secure, which means, let's say, even though isolation is happening, that is happening at a process level. Suppose you are not following some best practices, container best practices. There are some best practices. You are not following that best practices. Even though isolation is happening, if someone is able to get inside this container, will they able to get into the system, or will it able to get into some other containers? If you are not following some best practices at a container level, if someone is get into this container, do we able to access the system related resources and other containers also? Yes. So little less secure, but there are some practices, there are some best practices which you need to follow, so that you can secure your containers. You can secure your containers. That I will explain. What are the best practices to be followed when we are creating a containers or images like that? I will discuss that later. If you see this diagram, you can easily understand comparison. This is VM, virtual machine. This is container. Guys, I am not this much creative. I am not this much creative, but I have took some comparison diagram from the official document, some internet. You can understand. Containers size very huge. So don't say, guys, container is container is rat, VM is elephant. It is not like that. I am saying size. What do you mean by size? Does the container is lightweight like rat? Is VM is heavyweight like elephant? VM is not elephant, but I am saying size. Size in the sense, is VM is going to take more resources, like more CPU, more memory, because each and every VM has an operating system. Yes. So that's why it is very huge in size. And containers is lightweight. It will take less resources. And startup. Startup. VMs are like a tortoise. VMs are like a tortoise. So to configure or to start the VM, will it take some time? If you want to do some kind of a virtualized deployment, yes. And containers are very fast. Containers are very fast. Within a fraction of seconds, you are going to create a containers and that containers will be started. Integration is very smooth in containers. It is little difficult in VMs. But again, where containers are running, are we completely going away with virtual machines or physical machines when you are using containers? Is it like that? No. No, your containers will be running in VMs only, in your physical machines or virtual machines. But instead of deploying your application directly on that VM, you are deploying that application as a container so that we can run multiple applications as a containers. Each container is isolated. So is everyone clear? What is traditional deployment? What is virtualized deployment? What is containerized deployment? How it works? What are the challenges? So this is required before